Following a similar protocol for Unit 2, Math 1108, a practice test, I went to Web Test, clicked on Make a Practice Test, chose from Chapters 4 and the appendix, brought the items over from the left to the right. I'm going to have 24 questions. And we're going to start. Keeping in mind as we do a practice test, you are to view the example, pause, try to answer it on your own, and then I will give you the answer and the protocol to get the answer. So in question number 1 here, determine if the following expression is a polynomial. Well, to find out whether something's a polynomial or not, what would make it not a polynomial? Well, to have the variable to a fractional exponent. To have a variable when it's simplified. To have a variable in the denominator. Here, this is going to end up as 5 over x to the first, when you cancel out one of these x's. You can't have a variable under a radical sign. And you can't have a variable in the numerator with a negative exponent. Now, as we look at this here, there is no variable, and it doesn't meet any of these. So the answer for this one is yes, it is a polynomial. As we look at example 2, again, read it carefully. And what are you asked to do? Well, you're going to write the function they give you. We can combine the 1 with this decimal and get 1.0, let's see here, 1.13. There you go, that's better. And then the x represents the number of months, which is 9. So it's a matter of putting this into your calculator and rounding to the nearest cent. That would be 2 decimal places. Let's see what you get. When I put it into my calculator, I got this, and I have 3 decimal places. So reviewing the rule for rounding, if it's 4 or less, we just drop it. So this would be the answer. In example 3, they're asked to multiply these 2 binomials using the distributive property and then combining like terms. So you would take the 2x, multiply it by the second binomial, the negative 2, multiply it by the second binomial, combine like terms, and see what you would get. So again, the 2x times the second binomial, the negative 2 by the second binomial, distributing, combining like terms, you would end up with this. In example 4, you're working with the rules of exponents, and you want to have your exponents positive. So remember, there is an unwritten 1 there in the numerator, so we'll leave that there. And when the exponent crosses the division bar, the sign of the exponent changes. So here we had x to the 5th underneath. When we bring this down, we add 1 more to the 5th, and this becomes x to the 6th as a positive exponent. In question 5, it's a repeat of what we've done earlier. And again, this is the question. This is the equation, the function, and our x value would be 58.5. You want to put that in your calculator, but first, there it is. Now, when you get your answer, it looks like this, but they want it rounded to 2 decimal places. I've put 3 in there. And again, since the third decimal place is a 1, we're just going to drop it. If it was 5 or higher, that third decimal place, we would make that 6 a 7. Now, we went over the protocol extensively for this in class, and hopefully you've resulted in a shortened way of doing this, and I'm going to show the shortcut way. So if we have a certain amount and we want it to double, we had said that, let's put it over here, we're going to get 2 times A, that's the future amount. P then would be, what would that original amount be? Euler's E, RT. Well, we said we could convert this to its natural log form, but first we wanted to get rid of whatever was with the E on this side by dividing out the A's, and then converting what's left, and doubling this original principal would just be 2A. Take the natural log of this side and the natural log of this side, but we can do away with all that, go to our shortcut, and this is what we would end up with from this formula. There's the rate. We're trying to find the exponent t. So with this in mind, substituting, how do we get t by itself? Well, we're going to divide both sides by 0.06. So in your calculator, you're going to put natural log, parenthesis comes up, you're going to put a 2 in there. Then you're going to hit the division bar, and you could put parentheses or not, but 0.06, and you're going to round to 2 decimal places. So putting this in your calculator, let's see what you get. So I got 11.552 and it went on. Rounding it again to 2 decimal places, I go to the third decimal place, it's a 2. I'm just going to drop it. And this example, we're going to take our principal of this, invested at a rate of this, where it's compounded continuously. What would be the future amount, which is A, after 20 years? Again, round to 2 decimal places. So pause for a moment, see if you can just substitute into this formula. So it would be A equals 5800. Euler's E, the caret in there, and then in parentheses, the rate converted to a decimal, 0.045, times the 20 years. This is the times, 20 years. Put that in the calculator and see what you get. So putting this into your calculator, you should get this, rounding it to 2 decimal places, Our 8 is higher than 5, so we're going to drop this, add 1 to the 9, making it 70. And that is our answer. Recalling our rules for polynomials, is this statement a polynomial? Yes, it meets all the qualifications. But is it a monomial, binomial, or a trinomial? Well, terms are separated by either a plus or minus sign. So there are two terms, so this is a binomial. And this question is in two parts. Determine the degree and the coefficient of the leading term. Well, the degree of each expression is the highest degree of any one term. So here there's no variable. The degree of this one is 0. Here the exponent on this variable is 4. So the degree of this term is 4. So the highest single degree of any one term is 4. So the degree of this expression here is 4. Now, what is the leading coefficient? It's not the first one. It's the coefficient of the term with the highest degree. So as we look at this term here, there's a 1 in front of that, and you have to include the negative sign. So the leading coefficient is a -1. Again, lots of things here reflecting on our lessons. Looking at this one, is this term a polynomial? Notice it has a fractional exponent, so the answer is no. Continuing. All right, solve this logarithmic equation in terms of x. All right, take a moment, and what would you recall to do this? So as background to review, we said that 2 to the third power is equal to 8. 2, you recall, is the base, 3 is the exponent, and 8 is the answer. This is the exponential form. In the logarithmic form, we have log base 2 of 8 equals 3. Well, 2 is the base, 8 is the answer, and 3 is the exponent, just arranged a little differently. So we said in solving these, it's best to put it in its exponential form. So what would this be in its exponential form? Well, our base is 10. Our exponent is -2. And our answer is x. Well, 10 to the -2, remember that goes down below as 10 to the +2 in the denominator, is 1 over 100, and that's what x is. Here we are asked to square this binomial. It's one of our special products. And you recall the protocol was to take the first term and square it. That would be 64 x squared. Then take these two terms, and whatever sign is in the middle is this sign, which is 56. 8 times 7, 56x, double that, and that would be 112x. And then square this term, which is 49. And there you have a perfect square trinomial that we got from using that special products technique of squaring a binomial. Square the first term, multiply these two together, double it, square this term. Here's a case. Again, read it carefully. We're going to use that shortcut again. Now, if this A is 1, what would be the half-life? Would you go along with 1/2 or 0.5 would be the half-life? So we're going to take the natural log of this side equals, again, the right side just becomes the exponent part, negative 0.023 t. Now, how do we solve for t? Well, we're going to divide both sides by this, negative 0.023, negative 0.023, and we want to round to 2 decimal places. So put this in your calculator. Again, natural log, parenthesis, 0.5, then divided by, and then you could put this in parentheses if you like, a negative 0.023, and then you're going to round to 2 decimal places. Again, you're checking to see that you know how to put this into your calculator. When I did that, I got 30.136, so it's higher than 5, so I'm going to drop the 6 and make that 3 a 4. Now, looking at what we previously did and set up that exponential form compared to logarithmic form, can you do this one in your head? So what is your base here? X. What is the exponent? 3. What is the answer? 8. So what base to the third power is 8? And hopefully you know that it's 2. 2 to the third power is 8. That was the example we used earlier. Now here, as we look at these two binomials, if you recognize, these are conjugates. That is the product of the sum and difference of the same terms. When we multiply conjugates, we only get the product of the first and the last, because the inners and outers cancel out. So this will be 25 x squared minus 64. This is now described as the difference of perfect squares. When you factor the difference of perfect squares, it factors into their conjugates. This one's a little more challenging. Again, put it from its logarithmic form into its exponential form. So the base here is 16. That's the base. The exponent is a negative 3/2. And what we don't know is what would our answer be. So here's a case where we're going to make this exponent positive by bringing it down to our denominator, and this becomes 16 to the 3/2. Converting this now to its radical form, 1 over the square root of 16 raised to the third power. Now the square root of 16 is 4. 4 to the third power is 64. So this is 1 over 64. And that would be the protocol to get it. Now in this example, pretty straightforward. It's going to be x to what power? Well, here we're using the product rule. We just add the exponents. So x to the ninth. Determine if this is a polynomial. So if it were, it'd be a trinomial, but we notice this last term has a negative exponent. So it is not a polynomial. Simplifying this expression by using the powers property. So as we do this, this is going to be a negative 2 to the 6th power, adding our exponents. Now, anytime a base that's in parentheses like this that's negative and it's raised to an even power is going to be positive. If this were a 5 or a 7 or a 9, an odd exponent, this would be a negative value. But even exponents, a negative base raised to an even exponent is going to be positive. So put this in your calculator, or just 2 to the 6th power is 64. Now here's a little bit of serendipity. We're going to bring this negative 2 up across the division bar. It becomes a positive 2, and a positive 4 gives us 2 to the 6th power, which is again 64. All right. Now, we had said in lecture that there are a couple of ways to do this, but my preference is the vertical way, where we take this binomial and multiply it by the trinomial, set it up like so. So pause now, and then I'll do it. So plus 1 times all of this just gives you this, 2x squared plus 1x plus 1. Now normally we don't write the 1 there, but it's useful in computation. Now we're going to take this box and go negative 4x times 1 is a negative 4x. Negative 4x times 1x is a negative 4x squared. We're putting it in like term columns. And then negative 4x times 2x squared is a negative 8x cubed. Now we're going to just add these up, negative 8x cubed. Here this is going to be a negative 2x squared. This is going to be a negative 3x plus 1. And then you're going to carefully put it into your answer box. And again, checking your work never hurts. All right, let's go on. As we look at this, total attendance, read it carefully and see what you get. They're looking for what would be the projected attendance in 2030. So from 2012, subtracting the 12 from 30, we get our x value as 18. So put this into your calculator and see what you get. Now, in my calculator, it read 21122.8. So I'm going to drop the 8 and make that last 2 as part of a whole number a 3. And that should do it. As we look at this example, I'm just listing the function that they're giving us. But what are they asking here? What, from looking at this function, was the initial total number of sales? That is, x is 0. So let's use our eraser and make the x to the 0 power. Remember, anything to the 0 power is 1. So this is our answer. This to the 0 power, all of this is just 1. So our answer here, we're going to put in there, is 13619. Okay, that was a little tricky. Now here they're asking us to convert this to its log form. So we're going to put log. What is our base? Our base is 10. What is our answer? Our answer is 67. And what is our exponent here? K. So it's a matter of matching this up, and it looks like it's the first one here. Okay, just one to go. Find the amount of money that will be accumulated, and you're using compounded continuously. So A equals principals Euler's E RT. Let's see if you can set that up. All right, so 750 Euler's E. 5% is 0.05. 23 years times 23. Put that in your calculator and see what you get. So I get $22,265 and then rounding it 26 cents. All right, this should wrap us up.